Hi guys, and welcome to another video. Today's video lesson, we're going to be looking at Euclidean geometry, solving circle geometry problems, providing reasons for statements, part 4. The question that we're going to be looking at today is from the November 2017 paper 2. It reads as follows. It says, in the diagram below, two circles touch each other externally at point P. QPR is a common tangent to both circles at P. EDRC is a tangent to circle P, PBFC at C, RCA equals to Y, and DAC equals to X, and we've got AD is parallel to BC. First of all, when you are given tangents, remember that that is your key word. That means many reasons are going to have to do with tangents. So the first thing that you need to know about tangents, the most common one is tan chord. Number 2, you also need to know that the tangent is perpendicular to the radius or the diameter. And number 3, you need to know that tangents drawn from the same point are equal in length. So tangents drawn from the same point are equal. So that's everything to do with tangents that you need to know. Once again, with parallel lines, you need to know the following. Corresponding angles are equal, and you've got co-interior angles are supplementary, and alternate angles are equal. And this is very, very important whenever parallel lines are given to us. Then our next step now is to go and look at our diagram and look at, can we identify angles equal to each other? Don't forget that they tell us that RCA is equal to Y and DAC is equal to X. Let's go and have a look at our diagram. So here, our job now is to make sure that we can look at how many other angles are going to be equal to X and Y. So remember that we are given parallel lines. So straight off here, you can see A1. See, these lines here are parallel. So therefore, A1 and C2 are going to be alternate angles. What else can you see? Well, if you look here, A1 and E are going to equal to each other. That's going to be angles in the same segment. Then if you look at it here, you've got, they tell you that QR is a tangent. So you've got a tangent and you've got a chord DP, so X. So therefore you can see P1 is going to equal to E, it's going to equal to X, and that's going to be the tan chord theorem. And over here now, you've got C2, and then you've got another tangent here. It's a common tangent. So you've got tan chord again there. So P5, there's your chord here, which is PB, and it subtends the angle at the circumference, which is C2. So that's going to equal to X. So you've got 1, 2, 3, 4 so far that are equal to X. Let's just quickly look at Y. So if you look at Y, they tell me this is the tangent here. So let's see, tan chord, there's my chord, and there is an angle here at the circumference. So B2 is going to equal to C1 equals to Y, and that's going to be the tan chord theorem. Now, let's look at any other values, or rather angles, which is going to equal to Y. Well, there you go here. If that's Y there's your chord, which is PC, and there's your tangent here, which is now QR, so that's also going to to Y, tan chord there. So there's Y and there's Y there. Right, so B2 going to equals to P2 equals to Y tan chord. Now let's go see if we can answer some of these questions. The first question now says, name with reasons 4 other angles equal to X. And we've got them. Right, so we've got 4 X's here. 1, 2, 3, 4. So let's just go write them in that same order. So for 12.1, 12.1. Our first statement here will be, what did we write down first? Well, we wrote down here that, well, we've got angles in the same segment, right? A1 and E. Let's write that down. E equals to A1. You can say E, angle E equals to A1, which is equal to X. That's going to be angles in the same segment. Then our next one that we wrote down here, well, we've got P1 is equal to E equals to X tan chord theorem. So let's write that down. P1, 1 equals to E equals to X, and that is tan quad theorem. And then one of the first things that we wrote down here was that A1 is equal to C2 equals to X, and that is alternate angles. So let's write that down. So we'll say C2 equals to A1 equals to X, and we've written down that reason will be alternate angles, and that is because we're given that, there's it here, AD is parallel to BC. Let's write that down. AD is parallel to BC. And then we've got here P5 is equal to C2 equals to X tan quad. So we'll say P5 equals to C2, there's it here, C2 equals to X, and we can write down tan quad theorem there, and there we go. Right, so our next question, so we've got 4 other angles, or 4 angles equal to X. So there's it here, 1, 2, 3, 4. Let's go look at the next question. The next question says, show that EPA equals to X plus Y. So if I look at EPA, there's it here, EPA, so they basically want me to find P7. Now if I look at it here, I can clearly see that if I look at this particular triangle, EPC, what do you notice? I already got X and I've got Y there, and there's a line which is produced from now P to A, so I've got an exterior angle of a triangle there, so therefore that will be X plus Y. So P7 equals to X plus Y, exterior angle of the triangle. But if I also look at it from another perspective, I've got parallel lines here, so that will also be X plus Y. You can see that's X plus Y, that's corresponding angles, and D1 will equals to P7, and that will be angles in the same segment. So I've got alternatives here. Let's go and write down both of those solutions. So P7, so 12.2, I'm going to say P7 is equal to X plus Y, exterior angle of triangle, or I'm going to write down D1 equals to DCB. D1 equals to DCB. That's equal to X plus Y. I'm going to write down corresponding angles. That is because AD is parallel to BC. Then I'm going to say, but D1 is also equal to P7, angles in the same segment. They are subtended by the same arc here. If you can look carefully here, they are subtended by this arc coming down here, which is A. So therefore I'm going to say D1 equals to P7. D1 equals to P7. I can write it the other way around it, that P7 equals to D1, or whatever they ask me to find, which is EPA, which is actually equals to EPA, and that's equal to X plus Y. Then I'll just write down angles in the same segment. So that's about covers it there. 12.3, determine the numerical value of X plus Y if it is given that DCTP is a cyclic quadrilateral So we have to know the properties of the cyclic quadrilateral. And I think one of the properties that they want to test here is that the opposite angles of a cyclic quadrilateral are supplementary. So let's go and have a look at that. So let's go and look at what cyclic quadrilateral are we talking about? DCTP. So DCTP will be the following figure: DCTP. There you go. But remember that the opposite angles of a cyclic quadrilateral are supplementary. Now let's go and see that. So if you look at here, x plus y, so that's x plus y, vertically opposite angles, x plus y, x plus y. So P3 and P7 are vertically opposite angles. So now you've got x plus y plus x plus y plus x plus y, all equal to 180 degrees. Opposite angles of the cyclic quad are supplementary. So my first statement will be P3 equals to P7 equals to x plus y. So that's going to be 12.3 and 12.3. Let's go and just double check that one. I'm going to say P3 equals to P7. P3 equals to P7 equals to x plus y. And my reason there will be vertically opposite angles. Remember, vertically opposite angles are equal. And now I'm going to write down here that I've got this whole angle here, which is TPD, and I've got DCT. So we can write down here DPT. I'm going to write down DPT plus, let's write down DCT plus DCT equals to 180 degrees, opposite angles, cyclic quad are supplementary. So let's now go and sum all of those angles up. So it will be x plus y plus x plus y plus x plus y. So we've got 3 x's and 3 y's. So we got x plus y plus x plus y plus x plus y equals to 180 degrees. That gives us 3x plus 3y. 3x plus 3y equals to 180 degrees. So you've got 3 into x plus y equals to 180 degrees. Therefore, x plus y is going to equal to 180 divided by 3 is 60 degrees. So the numerical value of x plus y is going to equal to 60 degrees. That is, if you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.